Okay, welcome all. Today we are going to discuss the topic, which is the very first topic in this today's lesson. State the features of Intel 8051 microcontroller. Just for revision, in the yesterday's class we have started the new subject, that is microcontroller programming, which is present in the fourth semester of electronics and instrumentation branch in the C18 curriculum of SBTech Telangana. The subject code is EA402, and we have started the first chapter, and we have seen the objectives of the first chapter and completed the introduction of our microcomputer. We have discussed about the block diagram of microcomputer and what is the function of each block, and again we have seen differences between microcomputer and microcontroller, and then we enter into the topic Intel 8051 family. Now see the features of Intel 8051 microcontroller. So what it will have? Generally the 8051 microcontroller will have these features. First, it is a 8-bit microcontroller. It was designed by Intel in the year 1981. It is a 40-pin IC chip. It has 40 pins. It operates with 12 MHz clock and a single plus 5 volt supply. Its internal ROM, that is on-chip program memory, is of capacity 4 kilobytes. Its internal RAM, that is on-chip data memory, capacity is 128 bytes. It has external data memory of 64 kilobytes and external program memory of 64 kilobytes. It has two 16-bit timers or counters. Timers or counters, not timers and counters. The same timers can be used as counters also. It has 32 bidirectional IO lines. 32 bidirectional IO input output lines organized as 4 8-bit ports. 4 8-bit ports. 40 to port 3. Port 0, port 1, port 2 and port 3. 4 ports will be there, which are of 8 bits. So totally 8 into 4, 32 IO lines. It has one serial port and 4 8-bit IO ports. One serial port, and it has 4 bank register banks. We have here register banks of 4. 4 register banks will be there. 5 interrupts, in that 2 from external devices and 2 from timers or counters, and 1 from serial port. It has 111, that is 111 instructions, in which 49 are single byte and 45 are 2 byte instructions and 17 are 3 byte instructions. Just observe these features. These features will be available for every microcontroller. Besides these features, in the advanced microcontrollers, we will have some advanced features also, extra features also. And some of the features will be combined, that is multiplexing signals will be used. So these are the common and typical features of any microcontroller. Just you have to remember all those features, and in the coming lectures, we will discuss each and every point, each and every feature in this topic. We will discuss in depth. Okay, now? So first, people have to remember all these features. Now the important topic, that is multiplexing and demultiplexing of 8051. Figure shows data, address and control buses for 8051. So this is a figure which we have data bus, control bus and address bus. In the left side, if you see, that is 8051 is written in the middle of this IC. So that is the 8051 microcontroller IC, and the components. To the left side, we have connected a ground pin, two capacitors to the external clock pins, and the reset pin is connected to some arrangement, that is a capacitor and resistor, and we have a reset switch also there. And to the right side, we have connected different pins: port 3 7th pin, port 3rd 6th pin, and PSEN bar pin is connected to some external read bar, write bar and PSEN bar, and port 2.7 to port 2.0, or you can say port 2.0 to port 2.7, that is entire port second port, or port 2. Yes, there is a difference between second port and port 2, because port 0, port 1, port 2, port 3 we have. So the port 0 is called first port or 0th port, you can call. So that's the name. So you should be very careful while mentioning these ports. So port 2 is connected to A8 to A15, that is upper 8-bit address bus. Upper 8-bit because we have the lower 8-bit A0 to A7. A0 to A7, that is lower 8-bit address, is connected to some other port via some latch IC signal, that is 74LS 373 latch. And again we have data bus here in the bottom. Data bus D0 to D7 is connected to some, again port 0 to port 0, total port 0, that is port 0.0 to 0.7, and these are connected to the signals. And you can see there is the representation of this port 0 to port 7 signals as AD0 to AD7, that is address and data. Both signals, that is multiplexing of signals, multiple pins, multiple works are assigned to these pins. So it is an arrangement in which the external data and external address is communicated with this microcontroller that is connected. You can say it is, instead of connected, there is a word that is, sorry, I can't remember now the word. So I will tell whenever I remember the word. Now moving on to the topic, explain multiplexing and demultiplexing of 8051. We have figure shows the data address and control buses for 8051. Microcontroller follows Intel standard. It provides multiplexed address and data bus. That you remember that 80 to 87, we call it as multiplexed address and data bus. For demultiplexing, we use 74LS 373 latch, because to the left side of the 74LS 373 latch we have 80 to 87. To the right side we have address and data lines are separated, right? Initially ALE is high, address latch enable pin of 8051 is high, therefore this latch will is enabled. When ALE is high on P0, port 0, we get address, that is PCL, program counter lower byte. Therefore output of latch is nothing but A0 to A7 as ALE. After some time ALE is 0, the address latch enable is 0, therefore contents will be latched. Now even though input disappears, output A0 to A7 will be intact in next ALE cycle. At this stage, we are ready with data bus D0 to D7 and lower address bus, higher order address bus we get from port 2. Finally, in control bus, the signals will be read, write, or the WR, we can call it as read pin, write pin, program status enable pin, PSN pin, reset pin, and address latch enable ALE pin. So that is 8051 supports the multiplexing of signals, and with the help of 74 LS 373 latch we can demultiplex those signals. So this is an example where the multiplexing of this 8051 is possible, and how the multiplexing signals will be available to the externally connected 8051. Externally connected another ICs will be available with these pins. And don't bother about ALE high or low, that will come in the uh, next lectures. You can understand what is ALE, why it is high, why it is low, what happens when it is high, and what happens when it is low. Just remember this diagram. That is, no need to remember every point, every pin or nothing. Just see the port 0 is connected to for the multiplexing of signals, address and data signals. And if you can remember, that is EA bar, external access, external address should be accessed through the with the 8051 because of this pin EA bar. That is, bar means it is active low signal. EA bar, if any pin has some bar on the pin, then it is a active low signal. That means if there is a low input is given to the pin, then it will become active. Okay, active low means whenever we give a low input, whether it can be 0 or negative value, right? So if we give that low value, then it will become active and it will start functioning. If there is no bar, that is, see here, RST, reset pin, for example, in the left side of this 8051 microcontroller, reset pin, it is active high pin. That is, if we give 1 or high voltage level to this pin, then it will function. If we give the low input, that is 0 input, it will be disabled, it will not function. Now moving on to the next topic, that is draw the functional block diagram of 8051 microcontroller. Functional block diagram, actually one must draw this um, multiplexing and demultiplexing concept and explain. We should explain these each and every connection. So I hope please draw this diagram uh, at your home after replaying this video. Now see the functional block diagram of 8051, but one must draw this functional block diagram right now. Yes, you need to draw, don't bother about the size of this diagram, enormous size or complexity, but this is the important. You need to understand in this level that 8051 or any microcontroller, how the blocks, how the operations will be processed, how the data is stored, how the data is moved from one place to another section, right? So what are the extra features that a particular 8051 or particular any microcontroller will have, will be indicated through this diagram easily. So you must draw this diagram, and I will explain. I will read out those blocks for you. Just draw the diagram yourself. On the top side we have port 0 drivers, port 2 drivers, which are connected to the port 0 pins and port 2 pins. And below that we have RAM address register, again RAM, and port 0 latch, port 2 latch, ROM, read only memory. Then those are connected to a bus. You see the long pipeline structure below those blocks. So that is a bus which will be available and when the data is communicated with this block, the same will be available on the entire bus also. And below that, below the four blocks, we have B register, ACC, that is accumulator register, and stack pointer. And below that we have temp2, temporary register 2, and temporary register 1. ALU unit, most important unit, that is arithmetic logical unit, which is connected to PSW section, program status word register, which is connected to the bus. And again to the left side we have timing and control instruction register, and below that we have oscillator block, which is connected to extal1 and extal2 pins, which are connected to this external crystal, that is the symbol of a crystal, and both capacitors are there and which are grounded. And to the left of this timing and control unit we have progress status enable bar pin, ALE address latch enable bar pin, external access bar pin, reset pin. And in the right side we have program address register, buffer register, PC incrementer, program counter incrementer, and again below that program counter register, and again DPTR data pointer register. And below those things, below those blocks we have port 1 latch and port 3 latch, which are connected to port 1 drivers and port 3 drivers. Port 1 is connected to port 1.0 to port 1.7 lines, and port 3 are connected to port 3.0 to 3.7 lines. And in the middle section, if you see clearly, it is PCON registers, SCON, TMOD, TCON, and below that SCON below we have TH0, TL0, TH1, TL1, and SBUF register, interrupt enable IE, interrupt priority IP, and interrupt serial port and timer blocks. The entire section is called interrupt serial port and timer blocks, which are connected to this bus. So this is entire functional block diagram of the 8051. One must remember every block. Yes, in the earlier section, that is in the starting of this chapter, you may find difficult to remember all these things, but it is necessary, and you will remember every block because they will come again and again in the coming lessons or in the syllabus. We have every block will be explained separately and in depth also, so you can remember easily. But now you may seem it is difficult. What is this? Why we have to remember all these things? And is it this much enormous thing? Or you may think some other ways also. But I will guarantee that each and every one of you can remember all these blocks with the connections also. The connections also. In the coming days, you can draw this picture without draw this diagram without even looking at it. Yes, that is also possible. I hope everyone has drawn this block diagram. Now moving on to the theory part, that is explanation. Please keep this block diagram in front of you so that during the explanation you can find easily the connections or the blocks names. Even you can see it clearly. In the syllabus we have draw the functional block diagram. That is one objective on this chapter 1. And again in the second objective, that is below that 110, explain the function of each block. Explain the function of each block. First one is a CPU, that is microprocessor. We know most of these things. CPU is the general purpose microprocessors such as Intel's x86 family or Motorola's 680X0 family. The CPU of 8051 is capable in performing arithmetic and logical operations like addition, subtraction, multiplication, division, logical or XOR, rotate, clear, and complement. This type of logical operations can also be performed. The CPU can do bitwise as well as bytewise manipulations. It works based on the code written in the ROM. So CPU will be performing all these operations, that is bitwise or bytewise manipulations, based on the code, that is the software code, that is the mnemonics that we are going to write in the coming chapters, right? So depending on that code, if you write and if it load it in the ROM, internal ROM of this 8051, the CPU will perform accordingly with this by executing the code which is presented in the ROM. Now second is ROM or RAM memory. It's a memory. It is a fixed amount of on-chip or internal memories, right? If you see in the functional block diagram, there is a ROM and RAM to the left side and right side of the top section of this 8051. So these are internal memories. It stores programs and data temporarily during program execution. It stores programs and data temporarily during program execution. In other words, the program codes are stored in the ROM. In other words, the program codes are stored in the ROM, and the data could be stored in RAM. Data will be stored in the RAM. The program codes are stored in the ROM. I/O ports. 8051 consists of 4 I/O ports, that is port 0, port 1, port 2 and port 3. These are used for interfacing. Yes, this is the word which I forgot during the earlier of this lecture, that is I call it as the connection. 8051 will be connected to other ICs. It's not the connection, it is the interfacing. The actual word we should use is interfacing. One has to interface the 8051 with the other chips or other external devices properly. We cannot call it as a simple connections, because in the electrical circuits, in the electrical part of your study, you can call it as connections in the circuits, but with these ICs on chips we are talking now, they should be interfaced properly. We cannot just connect them directly. These connections will be there, but how they will be connected? What is the speed, whether the speed is matched, whether the proper programming instructions are passed from this one chip to another chip. So everything should be maintained properly. Everything should be balanced. Okay, so such type of all conditions will be come into effect, and they will be simply represented as a interfacing. The word we should use is interfacing. So these are used for interfacing the I/O device like switches, keyboards, LED, LCD or ADC, analog to digital converter, and DAC, that is digital to analog converter, etc. So number of I/O devices will be there. They all have to be interfaced with this I/O ports, and also for any other input or output operations. The external address and data buses are formed only by using port lines. External address and data buses are formed only by using these port lines. Now the next is serial port. Computers transfer data in two ways, that is either parallel and serial. In serial communication, the data is sent one bit at a time. The 8051 has one serial port for this purpose. It is full duplex, hence it can transmit and receive simultaneously. See, full duplex means it can send a signal, at the same time it can receive the signal also. Right? There can be simplex, half duplex and full duplex things. Next is timers and counters. 8051 has two 16-bit timers, that is timer 0 and timer 1. 8051 has two 16-bit timers, that is timer 0 and timer 1. Why I am reading again and again? Because these are all new words to you people. That means diploma level students, You may have heard about these terms, technical terms of 8051, or the pins, the pin mnemonics, that means this PSEN bar, ALE bar, these are all new terms to you. So if I read it again and again, you will be habituated with these words and you will remember easily. During your reading and your study, you can easily connect these dots. That means you can find this, remember these concepts easily. That's why I'm reading again and again. Okay, they can be used, that is timers can be used either as timers or event counters. There is to count the number of events, to count the number of pulses, or to count the number of event occurred. So they can be used as timers or event counters. Counters are used to count the events, whereas timers are used to maintain time delays. Maintain time delays between the actions. Next part is interrupt control. Next block diagram is interrupt control. Interrupt is a signal sent by an external device or from internal unit to the microcontroller so as to request the controller to perform a particular task or function. Interrupt is a signal sent by an external device or from internal unit to the microcontroller so as to request the controller to perform the particular task or function. You can easily see the interrupt is the English word interrupts. If somebody interrupts you during your work or during your study, then you have to attend to them what is their problem or what is they are talking or what is the work they have to attend. Then afterwards completion of these works, or then you give the answer to those persons who ever interrupt you. Then again you have to move on to your task, earlier task, that is either studying or reading, doing your homework, whatever it is. So the same concept here also there, and that signal is by external device or from internal units. External means some other person or some other thing, external environment. If it disturbs you, it is called external interrupt. And if it's the internal, that you have a cough or you have a thirst, if you have thirsty, if you are thirsty and if you are hungry, and if something happens to you, then you will take a break of 5 minutes or 10 minutes. And if you will attend to that, I mean, you go drink the water or you go and take a break. So that type of thing is internal, internal. And in the earlier part of this lecture, we have seen that is there are the features of 8051. We have 5 interrupts are there, that is 2 external and 3 internal, right? So those type of interrupts will be handled in this interrupt control block. The interrupt control unit transfers the microcontroller attention from one task to other. Next block is oscillator. The circuit generates the basic timing clock signal. The entire microcontroller has to follow this time clock signal. That is the whatever the commands it is sending or it is receiving, you have to follow particular clock signal to maintain the correct time. The coordination between the different blocks and external device also will be maintained because of this time. That is, we are following the timing of real world, that is seconds or minutes. That we say something different, if you bring that in this 1 minute or 2 minute, and you will tell something to him in this particular time, right? So here the microcontroller also will maintain um, this clock signal. Okay, this clock signal we can vary this clock signal, but it is limited by some particular operations or particular capacity of this processor or the controller, depending on the RAM and ROM and the address and the number of bits microcontroller. So these will all depend on this clock signal. So this is a very important block on the 8051 or any microcontroller also. So the oscillator box generates the basic timing clock signal for the operation of the circuit using crystal oscillator. Using crystal oscillator. If you can remember from the earlier EDC, electronic device and circuits lessons of my video lectures, Then we have seen about this crystal oscillator. Why we go to this crystal oscillator? Because of their high accuracy and high frequency stability. Stability is most important because it has to maintain the frequency, output frequency of the signal constantly, constant, okay, without any variations in the output waveform or the frequency. So that's why we use crystal oscillator, and it is very high frequency. That is, like example, if we take it is in the features P8051, if you have seen, that is 12 megahertz. We use it 12 megahertz, 12 into 10 power 6 edges, right? So such type of frequency, high frequency, has to be maintained properly, right? So that can be done by these crystal oscillators. The oscillator circuit generates a train of pulses at a frequency of the crystals. So that train of pulses is similar to a square waveform, right? Or it is a pulse waveform. Now, point: the machine cycle is group of 6 states or 12 crystal pulses. We should see this machine cycle is a group of 6 states or 12 crystal pulses. The state is the basic time period for the microcontroller. The state is the basic time period for the microcontroller to fetching an opcode, decoding the opcode, execution of an opcode, or writing the data type. So we have the pulses, right? Number of pulses produced by this oscillator. In that pulses, the group of pulses, the group of 12 crystal pulses is combined. That is, we are taking the group of 12 crystal pulses as 6 state, and that is equal to one machine cycle. So we should use this machine cycle term, while uh, estimating the time delays, or estimating this time taken to execute this one instruction, or fetching the data from one memory to the processor, or storing the data. So depending on all the operations has to be mentioned in machine cycle term. So what is the machine cycle here? It is a six state group of 6 states, and it is a 12 crystal pulses. Those crystal pulses are from the crystal oscillator, which will generate at 12 megahertz frequency. So remember these terms. And now next block is bus control or control bus. A control bus is used by microcontroller for communicating with other devices within the system, for communicating, controlling. Basically, bus is a collection of wires which work as a communication channel or medium for transfer of data. Buses are three types: address, bus, data bus, and control bus. Address bus, see, sorry, with this bus data bus, that is not. Three types of buses, that is address bus. Second one is data bus, not this bus data bus, okay, data bus only. And third one is control bus. Now next block is SFRs. So till now we have seen the different blocks, only simpler term, simpler explanation only. We will go in-depth explanation only what is that block, what it will do, how it will do, how it will communicate, what if something happens, what is the output if something is there, if some code is written. So that will be, you can discuss in the detail in the coming topics. This is only the outer layer, okay. Next block is SFR, that is special function registers. 8051 has 21 SFR, special function registers. These are the 21 special function registers, that is A register, accumulator register, B register, DPTR, data pointer register, PSW, program status word, IP, interrupt priority, IE, interrupt enable, TCON, timer control, SCON, serial control, PCON, parallel control, port 0, port 1, port 2, or port 3, and SBUF, serial buffer register, and some other registers also there. All these are byte addressable. Byte addressable means we have to address these registers and only byte. That means 8 bits has to be sent to this registers at a time. We cannot send only single bit to this registers, and we cannot access the single bit of this registers. Okay, we have to access the entire register, that is 8 bit has to be accessed. use other bits in that particular byte, we have to access, we have to write. If we don't write, they will take by default values or some garbage values also. All these are byte addressable, and some of them are bit addressable. Some of them are bit addressable. Bit addressable means we can access them through bits. That is port 0.1. That is the first bit or second bit of this port 0 can be accessed. Example: the SFRs can be accessed by their names or by their addresses. So SFRs can be accessed by their names. That is a, we can write in the program that is directly port 0 or A, B or DPTR, or we can write the address also. So every register will has a address, particular address. You can write the address also in the program. The FSR can be accessed by the names or by their addresses. These are useful in accessing IO ports, timers or counters, user, power controlling, etc. Next, timing and control unit. This unit synchronizes all the operations with the clock and generates control signals for proper functioning. So this is the timing and control unit, which is the most important block, because we have the clock signal that will generate the pulses, and we have the blocks which will use these clock signals. But what is the coordination between these blocks and clock signals? That is timing and control unit. So how many machine cycles one clock will use, how many clock pulses, right? How many clock pulses are used for this transfer of data, or to fetch this data, to execute the data. So depending on the number of pulses which are pre-feeded in the microcontroller will be shared by this timing and control unit. Okay, it will manage the entire, this is like a manager, HR in the real world. It will manage the entire operation of this functioning or of this X05. Next is instruction register. It is a 8-bit register. When instruction is fetched from memory, it is loaded in the instruction register. Instruction register, it is an 8-bit register. When instruction is fetched from memory, it is loaded in the instruction register. It holds the instruction which is to be decoded. It holds the instruction which is to be decoded. It determines the operation to be followed in executing the entire instruction. Instruction register, it is a 8-bit register. When instruction is fetched from memory, it is loaded in the instruction register. It holds the instruction which is to be decoded, determines the operation to be followed in executing the entire instruction. Next is temporary registers. There are two 8-bit temporary registers, that is temp1 and temp2. These are also integral part of ALU, arithmetic logic unit. Arithmetic logic unit. The unit we have this temporary one and temporary. We use this temporary one and temporary registers. Comparisons and certain other operations are used the contents of these registers. So with this we completed the functional block diagram and the explanation of each block. Simpler explanation, not the detailed explanation. You have seen. Okay. So in today's lesson, we have seen the features of Intel 8051 microcontroller. Once again, please read and remember this 8051. I can continue with the next topic also. Today we have another 6 to 7 minutes, but I want you to revision this whatever the topics I explained today, because this is a little bit of different subjects compared to other subjects. That is core subjects like electronics things, and this microcontroller is a different subject. It is like a software part, and first you have to learn the hardware. That is what it has. the entire skeleton structure, what components it has, what blocks it has, and why they are there, what they will do, how they will function, which instruction has to be given to the conditions. Some of the conditions will be there. Some are beta testable, some are beta testable, some will be high active high pins, some will be active low pins, and which pins are used, and should remember each and every point in order to make it work, make the 8051 to be work. So the coding part is important, it is the logical part, but before that we should see what features we have, what are the assets we have, so which can be used to execute the program, and how the external device, that is in the display unit, there is no display unit in this 8051. We need to interface the LED or LCD and the keyboard, which we have to write for the input and other things of the more if you connect the stepper motor, and many interfacing circuits will be required in order to function a particular application. We have seen the applications of this microcontroller in the real world, and have industries. Every industries, every household will have at least one of these 8051 microcontroller. Okay? We have some printers and washing machines, normally refrigerators, TVs. So in every application, in every electronic appliances, we use 8051. So we need to learn it step by step and clearly, and we have to understand it properly. So it may be a slow learning, but we will compulsorily learn it and remember it properly, and we will use it in real life also. You can do you can make the project for your diploma completion or BTech projects also there. So um, we can today we have to revise the topics whatever we have explained. So the features, most important thing is what features we have. The 8-bit microcontroller designed by the company Intel, and the year 40 pin IC, 12 MHz clock with plus 5 volt supply, on chip RAM of 4 KB, 4 kilobytes, internal RAM of 128 bytes, external data memory 64 kilobytes, external program 64 kilobytes, 2 timers or counters of 16 bit, 32 bidirectional IO lines, that is organized in 4 IO ports, IO port 0 to port 3, 1 serial port and 4 IO ports, 4 bank registers, 5 interrupts, 2 from external, 3 from internals. That is the timer and counters, and 1 from serial port. The instructions, number of instructions available, that is in that which are single byte, which are 2 byte, and which are 3 byte. Concept of multiplexing and demultiplexing. Examples of this multiplexing and demultiplexing with 74 LS 373 latch and different types of connections. What type of inputs will be there, where we have to connect these external signals, how the latching will be there, how the multiplexing and demultiplexing will be there. And functional block diagram. One must draw this and remember the every block, how they are connected, how they are arranged. This arrangement is also very important, because the speed of the microcontroller, speed of the execution of the instruction also depend on this arrangement, where we connected these um, latches and these RAMs and ROMs to the CPU or the processing unit, address latch unit, or ALU, arithmetic logic unit, where we have LEDs connected in central part, and the timing and control signals can connected to the end of this IC. Then ports 0 to port 1, port to port 3 are connected to end, and external clock signal is made available with this external crystal resistor is connected, crystal oscillator is connected. So this type of arrangement, 8051, the designing of the 8051 is another level subject, but we are only studying studying after the designing process, what it will have, what the features and how it will work, and what is the code we have to write for our application based. Now the designing process we are discussing here, but this designing process is another level. And we have seen different blocks and what they will do in the microcontroller, that is how they are connected to other things, IO ports, serial ports, timers and counters, and interrupt control, oscillators, bus control, SFRs, and even control instruction register, temporal registers. Okay, so register structure is next topic, and we can discuss it in tomorrow's class. So with this, I conclude today's lesson. Please draw this function block diagram. If you do not draw it now, you will have no time to draw it during the coming days. And during the exam, if we ask the question to draw, then you will get confused which block operator, which block, and how the connections are there. Yes, they will be asking in the exams, but it is not for the exam section I'm talking about here. But this function block is the basis for the entire understanding of exam. So which blocks are there, how they are connected, right? So that is important. Please draw this diagram now itself. Don't forget to draw it, right? After concluding the session, you can draw it at your home. And thank you. With this, I am closing today's lesson. Thank you one and all.